This is the CPO Science Wind Turbine setup. The CPO Science Wind Turbine is an experiment that teaches students the concepts of electricity and magnetism, energy and energy transformations, and other sciences through the lens of science and engineering and technology and design. The wind turbine comes with many parts, so we'll go through those first. The first important part is the base, and the wind turbine base has several other parts already connected to it. One is the magnet rotor, which is red, and the other side is the blade rotor, which is blue with the yellow knob. And the green part is the coil holder, which holds the wire coil, and the gray part is the core holder. And then also on the base, there's a socket for connecting a light bulb and banana plugs for connecting the wire leads, and also holes for putting in a digital meter or using the data collector to measure electricity. Also comes with a wire coil that has 2 leads coming from it, and it comes with 12 magnets, and it also comes with a metal core and 2 light bulbs and 4 blades of 3 different blade types. So we have round blades, 4 of those, and we have what we call flame blades, and we have 4 of these, and we also have 4 long blades. And the set also comes with 6 blade roots, which is this blue part right here. It comes without blades attached. And those are so kids can make their own blades, design their own blades, and try those out of any material they would like. So those are the parts. The other optional parts, you'll need a fan. And a good type of fan is a small fan like this one that has 3 speeds. I like this one because it's made of all metal and it's pretty powerful. You want a low, high, and medium speed. And you'll also need a device for measuring voltage or current. And in this setup, we're going to use a digital meter, but you can also connect the CPO Science data collector. Okay, so let's go through how to set this up. I want you to keep in mind that this is an open-ended experiment, and we don't want to tell kids the exact way to set this up. What students do is they do this experiment is they set it up in different configurations, and they change those configurations until they generate the most electricity. And the goal is to generate enough electricity to light one of the light bulbs. So they try different blade shapes, they try numbers of blades and all sorts of variations until they get the bulb to light. And we don't want to tell them the right answer. So one of the first things you do is you put in the light bulb. Just put it right into the socket. And the next thing is to attach the magnets. And I wanted to show you that the magnets have 2 sides. They have a north side, which is white, and the south pole, which is red. And the magnets also have a notched end and sort of an end with a hole in it. The notched end is the end that goes into the magnet rotor. So let's put the north side up in the first one, and if you put it in, you can hear it snap into place. Now, one of the things we want students to discover through this experiment is that you need to alternate the poles of the magnets on the rotor in order to generate electricity. So the first time students put the magnets in, they may put them all in one side up. They can also vary the number of magnets they use, so they could use just 6 magnets instead of 12. They don't have to use all of them. But let's go ahead and put in 12 magnets, and let's alternate the polarity. And it's very easy because you can see there's a white side and a red side. Okay, the magnets are in. The next step is you want to install the wire coil and the leads. And you place the coil in the holder so that the leads are pointing down and toward the outside. And it snaps into place. And you can see that it moves up and down. One of the variables in this experiment is the kids can vary the distance of the coil from the magnets by sliding this up and down. Another variable is they can actually change the orientation of the coil by pulling out, and it snaps back into place. So you can either have a vertical or a horizontal core. So the kids try different configurations to see which generates the most power. We'll put ours in the vertical position. And another variable is using a metal core or not. So the kids can either use it or not. They can try it with it first or without it first and see which works. We're going to try it with it in our first setup. And it snaps into the core holder very simply. And you can slide you can either slide the coil up and down, or you can even slide the core holder up and down. But it goes right through the center of the coil. Another option that kids could do is if they want to try the horizontal configuration, they can turn it this way, and then the core actually will slide in that way. So that's another way they might do it. But let's go back to our original setup that we were working with. Okay, and then the wire leads, now you want to attach those to the banana plugs at the base. So you can attach the red and the green on either side. Let's put the red next to the base and the green on the outside. And to attach a device to measure electricity, our digital multimeter here, you place the banana plugs right into the holes at the base, and we want to line the red up with the red, and the black one line it up with the green. So that's in place. So now we have the base set up and all of the parts. We just need to now choose our blades and attach the blades. The blades go into the blade holder, which has a yellow knob, and you'll notice when you turn that yellow knob, the holes open up wider, and then you can close it to tighten them in. So let's open up the holes and let's put our blades in. And I'm going to choose the round blades. And the kids can also vary the number of blades, so they can go with 2 blades, they can go 3 blades, or 4 blades. Let's just try 3. So it's pretty easy to figure out how to put them in there because you just put them in the hole, and then to spread them out, let's actually spread these out evenly. Let's go every 1, 2, 3 holes and put it in the 4th one, and then we'll put the 3rd one right there. And once the blades are in, you turn the yellow knob to tighten it in. And you want to get it fairly tight. Okay, so our blades are in, they're tight. Now another variable is you can vary the pitch of the blades or the angle. And the way to do that is just simply turn them. And with the knob nice and tight, you can turn the blades and they stay in place. So let's just give it a slight pitch. And you want to make all the blades similarly pitched. So now we have our 3 blades in. We've got them set at a pitch. And we've got all of our, we're going to try it with the core and the coil. And now the kids can decide what distance they want the coil and the core to be from the magnet rotor. And so let's just move it up about to there. And let's move our core up so it's even with the coil. Like that. So we have it set up. The next step is you want to use your fan, and you want to control the distance of the fan from the wind turbine. And to do that, the way I like to do is I like to use the multimeter, and I set it between the fan and the wind turbine. Let me just move those out of the way. We need to have the fan at a level with the blades. So when you're doing this in a group with your students, you want to make sure that each group has this setup exactly the same, because you want this variable to be the same. So I've got the right distance of the fan from the blades, and the fan is at the right height. Now let's turn the fan on to medium power. And give it a minute to get the blades to start to turn. and we turn our multimeter on. Now you can hear a little noise here. This might mean there might be too much friction. So one of the things the kids might want to change first is they might want to decrease the distance of the coil and the core from the magnets, because there's an attraction between the metal causing friction. So let's turn our fan off. Let's make that adjustment. Move it down slightly. And what kids would do is, since they're trying to come up with the best design, they need to record each step that they do and only change one thing at a time. Write it down what they change and then record the voltage so that they can see each change and its effect on the voltage. That's really important. And then do this until they get the best design that actually lights the light bulb. So we just made that minor adjustment. Let's try this again. Sometimes you have to give it a little start. You can see the multimeter, the voltage reading, it's going up, but the blades aren't turning so well, so we need to make another adjustment. So let's try one more thing. Let's try the change in the pitch on our blades this time to maybe a little more slight of a pitch. Okay, let's try that. Okay. So let's make another adjustment. Turn our fan on again. All right, that adjustment seems to have worked. We have a little bit better voltage here. Sometimes it takes a little while to get rolling. So that's the idea. The students can make different changes in this, record them, and keep making changes until they get the best voltage possible that lights the bulb. So now we have all the variables just right, and we have enough electricity to get the bulb to light.